Okay, it looks like we're recording. Well, hey, welcome everyone. It's great to see such great folks joining us today. Our agenda essentially is I'll give a current state of where we are on the study, and then I'll introduce you to our new income, or not incoming, but continuing students here at the UC Davis that are helping with the study and learning about estimating in extreme conditions. And then we'll talk about the white paper, and then we'll move over to Patrick Duke, who has been gracious enough to help us organize, because the group's getting larger, and as we get more into it, it's getting more complex. And he put a very good implementation plan together, which maybe you've had time to look at, but it's a really good plan. Because now what's happening is we're actually starting now to put all the pieces together, and what we're finding is this is so complex, and you'll see it as I go through kind of a presentation here for you, that we're going to, the white paper, getting that complete is one thing, but the subsequent work that we do is really where it's going to be very complex, and you'll kind of get a sense of that today. And so if you don't mind, I'm gonna do this here, and I'm gonna share my screen. Let's see. Can everyone see my screen? Okay, perfect. So as you may recall, this is the theory, the master theory that was developed. This is kind of a comprehensive, and it's okay because the white paper is going to explain the flow, but I think it's important, because there's a lot going on here, and we've kind of explained different components through through the study group, but this is kind of the one we're settling at right now. And we'll get in that's one aspect, though, of the complexity of information that we're trying to isolate. So this is more about how would a prediction of cost and time, very complex processes, how would it even flow? How would the data flow? How do we get the verification on and on? We've talked a lot about that. So that's really pretty much what the white paper is focused on, with offshoots. And I'll give you an example. Dr. Vishesh Singh, who I believe is online here, has contributed to the white paper on the predictive aspect of verification of our prediction. Dr. Brad Hyatt contributed so far on the business case side of prediction, and there's a couple more people that are contributing. I'd like to give their names. Patrick Duke will be writing a section on procurement risk. I believe that's what you're focused on. Yes, and Jennifer. I can't believe Jennifer Taylor with HDR is writing a section on cycle jumps, which is really fascinating. Dr. John Harvey here at the University of Davis is writing a piece that takes this theory and applies it to things that are being to a practical application that's very like this predictive aspect of it, where Caltrans is using here the state of California to predict cracks on highways before they actually happen, based on very complex criteria. It's really fascinating, and it's very much aligned to this. So you know, it has some practical application. Steve Fehr with NASA will be writing a small section, or a section on return on investment. Mark Hamburg will be writing a general section. He's with NASA, a general section. And if you want to write a very generalized section on your field, please contact me. Reach out to me directly. If you know, we'll figure out a way that where your expertise will reach into this theory. But be aware that the theory that we're doing, this first white paper, only sets the pavement. It only sets the freeway of how the information flows. There is so much work to do. How we integrate with NASA's work breakdown structure and their probability theory that they've developed, which is actually fascinating. And also how the expertise offshoots of the whole process, how there'll be offshoots of papers from this main paper. So there's plenty of areas for everybody to get involved in, to get your #1 name associated with it, and also share your expertise in the industry. So I wanted to remind folks that there's different kind of levels that we're dealing with. The first is the theory. Now I want to show now this is the general theory of how the estimating process works. This is a layover of the different lenses of expertise that touch the different areas. And as you notice if you go to the data room, these are broken down in your areas of expertise. So, and many of you have already have filled out the form, so we understand how we can start putting together focus groups, which Patrick is going to be managing. But before we go there, I want to talk about the rendering very quickly that Jabu with Johns Hopkins Applied Physics Lab did a presentation about a month or so ago. And so this is a kind of a very, very fictitious, but it's a starting point of what would a moon base kind of look like. It was a fascinating presentation. I hope you have the chance to go and see the recording if you haven't seen it already. So the task is, how would we even break out an estimate like this? And right. So I have an example to show you. And the example also shows you the complexity that we're dealing with. Look, I've been estimating for 30 years, and many people on this line have been estimating longer than me. And when you see how this can really spiral and cascade into some complexity, this is pretty monumental. What I really liked about Jabu's presentation is not only what he presented, because we had to squeeze it into about a half an hour, but if you look, and it's posted on the data room, if you look at the full presentation that has kind of the science behind what drives some of these things. And there's one that's really compelling, which it takes a human and it dissects what do humans need in kilos to sustain life, and what are the byproduct of the human, the output in kilos. It's fascinating. And then they use this for these calculations. But it does illustrate something, is that estimators will need to be into the science quite a bit, and that's why we'll have to really roll up our sleeves on this. And I'll show you a couple examples of this. So I wanted to show you this rendering. Now, before I go into the breakouts of an estimate, and this is beginning. I mean, we need a team to do this. It can't be just a small team. It has to be a multifaceted team. I'm going to go into this just to illustrate something. Now, so we have the process of what the estimate, how the data flows in the estimate and the coding and things of that nature, and how we verify and predict and do probability analysis, and it's in almost real time, and how complex it is. This is an example of the design and construction, or pre-con, if you will, of how things are structured, and it starts illustrating how complex things. Now, very quickly, because I'm looking at the time, we're breaking things into three categories, essentially, main categories, which is pre-launch, launch, which is a big deal, right? And then post-launch. And post-launch, obviously, is when we're moving into the actual construction activities. So I'll just walk through very quickly. So in pre-launch, and again, this is a much larger thing. It's just to illustrate the complexity of this process. Mission vision. And then from mission vision, you have your manufacturing. All of these things that we're using, unlike a hospital, aren't going to be you buy from a manufacturing out of a catalog. These are probably these are all manufactured specifically for a very specific thing. It all comes down to payload, and I'll explain why. Because if it's not a payload, it's just staying on the Earth. So that's a very important restraint. Then we go into deploy. Once it's in space, we have to deploy the whatever it is. Then we have to think now, well, you think it at the beginning, but then we have to stage. You're either staging in orbit and then land it, or you're going to stage it on the surface. Then we have to set up our make ready, and we'll see how complex this is when we get into some of the breakouts. And then we have to construct, and then we demob. So when we move down now to the next level, and these are kind of time sequence, but once we get down further on the sheet, don't think of it as start, stop, start, stop. These are just to illustrate the process. Next is the next layer is cost, time prediction. We have to start cost and time prediction at the very beginning stages. Then once we get to a certain point, say from payload on, it's not necessarily, as we mentioned before, the cost of the material is done. We already have that. It's maintaining full return on investment, and also then it turns to production time. And as a reminder, a general rule principle that we're using is 1 astronaut equals $2 million a day to support on the moon. That was taken from an International Space Station, and then escalated, and then put a modifier for the complexity of having them on the moon. So plus or minus, right? All right, so now well, let's get to the kind of the general tests, and this would just be just kind of the process involved. So at the very beginning, we have the mission statement, mission articulations. What is the exact, more specific purpose of the mission? Mission business case, mission budgeting and cost and time. Now, this is extremely important, as we know, at the very beginning. So what we want, all of this other stuff has to be figured out, but it all comes down really to how articulate the estimate is at the very beginning stage. So things have to be moving quite a lot at the very beginning. Then we have mission outputs, and it looks like there was some verbiage. Mission outputs and a master plan, kind of like Jabu put forth to us. And of course, that's going to change as it gets more real. Mission funding sources, obviously, research development, mission validations, in other words, constant validation. Now we move into kind of a different realm, which is how do we isolate the different things very early in the beginning? And what we've isolated so far is development of multidisciplinary system flow and comprehensive, complete cascading for all phases. Now, NASA and Johns Hopkins and all the think tanks are thinking of a multidisciplinary, but they're not necessarily, I shouldn't say they're not. I think this group needs to focus on the construction side of it, not, understanding what they're inventing and understanding their need, but always thinking about production and what ifs and moving it into the construction schedule and like means and methods and make ready, and we'll get into that a little bit. But establishing also in estimating, establishing what's current off-the-shelf technology, what's close technology that they can probably modify, and then what's technology that we have to predict that they just have to invent. It's not ready yet. And we have to have buckets for all of that. Now, NASA does have this. And look, the more I get into this team gets into it, the more I'm reminded by the team, and I have a realization myself, is that NASA has a tremendous amount of information that they have decades and decades and decades of research and development for even finding costs. But remember that NASA does not have necessarily historical or practice in construction estimating. It's satellites, rockets, one-off missions that are deployed pretty much, not constructed. So this is a whole different. Yeah. This is a whole different way that we have to approach this. Now,
hey, Paul, just NASA, yes, we do a lot of terrestrial construction as well. All of the NASA centers have buildings and things, and we do build them, although a lot of what we've built has been built a long time ago. So I would not necessarily say we're the world's experts in facility construction, but we do have some experience.
Yeah, so that's a good point.
Just different folks usually involved in.
Sure. Yeah. Thank you, Steve. And I find myself maybe I tend to lock myself into extreme condition construction is what I meant. So sorry, and I appreciate that clarification, Steve. Thank you. As you get into the action, it brings up another thing. When you read through, and it's mandatory reading if you want to be a true, a contributor to the group, you go to the primary reading, and it has construction handbook by NASA and things of that nature. It is very sophisticated, and it's something that we all should brush up on. Certainly if we're exploring something like this. So the next is coding. Coding is going to be very complex, and it's going to be, it really needs to be a multifaceted team. Now, NASA does have, and I would encourage, please, everyone, review the work breakdown structure handbook by NASA. It looks like this. It's on the data room. It's fascinating. There's a little more limitations than I originally thought. I thought that they have 7 criteria for coding, the project number, and then a series of 6 more, but they're 2-digit codes. And for us to intertwine construction and prediction and getting the proper historical, so it keeps getting smarter and smarter, essentially estimating historical. Our team's thinking that we're going to interact with not only the WBS that they have, but we're going to add in back of that more complex, more construction related coding as an example. And it does need to speak, I believe, based on the handbooks I'm reading with NASA, they're very specific. it would need to meet NASA's NSM, which is NASA System Management System, their financial system, which makes a lot of sense. We have Omni-class, which is a form of construction coding. We have uniformat, and then we have master format, which is all of these are different type of codings that we have to toggle back and forth on, because they all have, for construction, they all have very specific needs. And then also a hybrid of multi-dimensional coding, which interacts time and sequence and return on investment and things of that nature. So these are things that, as part of the pre-construction side of it. And then, of course, now we have the attributes or other things, for instance, the governance, which kind of, decision-making and, how is the estimate interacting with that. So we have the governments, not only NASA, but other entities as well. Abstract subjective analysis that need to be performed, model-based program design, cost physics. In other words, the physics cost would be so much rocket fuel is needed to take a payload, up into space. That's physics. It's very easy to estimate. How much is it going to cost to build a berm that may be encapsulated so somehow, for a landing pad, blast zone or whatever that is, maybe not so easy, so that's going to be a mix between the two. Let me see, multi-lens range reporting. In other words, reporting systems that aren't just for the team, but very specific for the business lens and the prediction lens and the risk lens and the production analysis folks. So we need to glean or grab the information out of the estimating system that can have very specific reporting for very specific lenses. Probability analysis, risk on investment, return on investment, excuse me, business output, and also engineering models and probability models, things of that nature. But anyway, so this can keep going and going. It's just to kind of illustrate the complexity. Now, I want to talk before we get into some breakouts, just to give you kind of an example. I want to talk about now moving this into the lens of construction. So what we want to now is you have, once it's a payload, once it's deployed, whether it's deployment could be in orbit, or it could be actually landing on the moon and starting that deployment of that mechanism physically on the surface, depending. And assuming most things are modular, but they have to be moved and put together. So we have things like general requirements, and which are could be problematic. Mission project sequencing and make ready. And we have some examples of that I'll share with you. Prep work, mock-ups, means testing. As we mentioned before, the data you read or the references you read, the plan isn't where you would just go in and build a whole building. You're going to take sections, and it's going to be tested, and small mock-ups are going to be implemented and see, does it work before you commit to such a large scale thing. I think the estimators on this call are really starting to grasp the enormity of what we're talking about. And then moon excavation, which is a big deal because of moon regolith complexities, retaining and backfill, and then we go into foundation, superstructure, exterior systems, core and shell systems, and these are just, they just keep flowering out. Interior fit outs, commissioning, online sequencing. In other words, online meaning you're pulling them online, which would need to happen sooner than Earth, obviously, because the systems need to be, ready for habitat, or at least environmentally sound. So that would be way higher in your sequence. And then service and facilities management systems. And then demo, but then, then you would have your maintenance facilities. So what I'm going to do is, let me just move my bar here really quick. Are there any questions right now on that? And then I'm looking at the time. I've got to pass it over to Patrick. So I'm going to spend only about 5 minutes to go over what would some of these breakouts mean. And I think when you read some of these breakouts, you'll probably for estimators and folks on the call, you'll have, I think, a good sense of the enormity of potentially what we're looking at. I'm going to pause. Are there any questions right now? Okay. So let's talk about potentially what the breakouts would be. Now I'm going to go to this rendering, and again, Jabu is very wants to be very specific, wants to really emphasize this isn't what the base will look like, but this is an exercise, a thought exercise that had multi lens folks from NASA and Johns Hopkins and people in the aerospace industry that said, well, here is potentially what a moon base would look like, just to start from, just to help us understand, or help the community understand. And with that comes all sorts of really good analytics that we need to think about. So when I start going through some of these breakouts, think about these as far as, number one, sequence and different breakouts of the estimate. And as opposed to just one estimate moon base, it will be broken out into the different segments. So let's just see. Let's just kind of walk through some of this and see what are some examples we have to deal with. Now, remember, the coding is going to be very complex, and that needs to be a breakout team to really understand what is the best way to code. Okay, so here is just kind of a general, kind of a major breakout of what we're looking at. You can kind of read through. That's very, very basic. And then for each section, it gets a little more, for the habitat. Within the habitat, there's going to be, these sections, where you suit up, suit down, residential quarters, medical. All of these would could be possibly, we don't know yet, could be different modules that are set together because they have very specific uses. But be that the case or not, we really want to learn lessons from complex projects like hospitals, which it is imperative that the owner and in design that we understand what an OR cost, or a hybrid OR, or a CUP, and have that same type of, instead of just, well, the cost of a hospital is X, what are the different components of the hospital, and what's in it, and how much does it cost? So you can see that, it has science centers, and, and these are just kind of brainstorming kitchen facilities. And then we go into launch and landing sequences, refueling maintenance, and on. And we're gonna drill down even further, because I want to go through a lot of these so you get an idea of, like, okay, I do understand the complexity. Because if you take, like, for instance, stabilizing, this one for transportation and roads, we're stabilizing lunar regolith for roads and dust. Think about just that one line, how that would break out into several more lines. And what's going to be important is that now we're talking about time and mechanics, mechanisms to actually do the work. And so it has to be, here on Earth construction, we may give unit costs. Well, it's going to be X, but because of construction on the moon could be compounding if mechanisms break down, or the regolith isn't working the exact way that we needed, and it's, we're talking of, maybe hundreds of thousands of cubic yards of regolith, potentially. It could be very problematic. So that's why we need to break these down into very detailed components of time, and mission, and whatever. But that's just one facet of many of the items that we would have to consider. So I'm going to not spend too much time on that. And let me move to, I'm going to move this over a little bit so I can see all of the, so we'll go into foundations now. And you can see kind of with foundations, all of the, and again, these aren't numbered out yet because we have to come up with a numbering system, but you can kind of read through here, layouts, excavation. It says earthwork. Sorry, that was a typo. My bad. But you can kind of see all of the components that are. This is just for foundations. I have checklists on the other thing. So this is what the team is just starting to work on right now. Regolith batch plant. Are we bringing, it's a payload. And so, right now, most of the research is trying to figure out how to use existing material from on the moon, as opposed to bringing it there. Construction, mobilization, which is so much complex than what we are used to here on Earth. If we were building a hospital campus, our means and methods and construction mobilization would be so much less complex than the things we have to think about here. I'll just kind of move down here a little bit. And site work infrastructure. Getting the infrastructure, it's probably, electrical, let's say. It's not going to be generated, obviously, potentially from a CUP plant connected to a habitat. It probably will be more than likely different systems, maybe not in proximity of the habitat. I'll just kind of keep moving down here. Mechanical and plumbing for the different systems. Right. Electrical systems, mechanical systems, same thing with electrical systems for habitat. Interior fit out. What would the interior be? What type of flooring, walls, casework, and everything is specialized. And it has to also be brought up, obviously, per payload. These are going to be very important. These are the umbilical. Let me show you where this is real quick here. Let me see here. Looks like I can't get over there. There's something on my annotate. Oh, there it is. Oh. Well, I have something on. There we go. Let me just show you something real quick. These corridors are umbilical. Well, things are pretty important because it, not only for safety reasons, but there's a lot of functionality, separating these systems. Let me go back here real quick. But each of those, they'll connect each of these, and each of those are very complex, even though their function more than likely will be just to connect the two systems together. Exterior systems. Radiation protection layers. And here's an example. I want to go back to this real quick. And it just shows the complexity of why it's important that estimating really understands what's going on. I'll give you an example. Yeah, this one. You see right here where it says exterior systems. Well, if there's an exterior system and it's underground, that's going to be completely different estimating, perhaps systems that are that are built if it's underground versus above ground. And to kind of show how this can really be complex in estimating is if you build a lot of Regolith, and I haven't heard a lot of talk about this, but there's a couple folks that are starting to write on the Regolith charging. If you layer Regolith on top, there is a compounding. Um, in other words, Regolith has electrostatic charge. And the more you increase, there is a potential of increasing electrostatic charge. And I regardless of where that goes, it's important that in that estimating process that we understand the risk, and therefore, is it above or is it below? And each one has a completely different construction process. So you can kind of see superstructure, exterior, all of these are just, again, estimating breakouts. So I'm gonna stop there, and because I gotta get, I'd like to introduce a couple folks. Are there any questions or comments on what you've seen? Fred, what's on your mind?
I've got to learn how to use my mute button, apparently. I'm amazed at the detail you've gone into as far as organizing the estimate. Those categories are great.
Well,
really help.
I'm going to put this on the line, but I think the important thing is, it's like all the estimators on the line are going to get this, is when you have a complex project, you always start, it's overwhelming, right? Because there's just so much stuff. But when you start layering out the theory behind, or the structure of how you're going to, where everything has a home, and that, for me, when the team was working on this, it started to become more like, okay, you get more anxiety because it's so complex, but it also creates a level of comfort. And that's what this, kept me up at night, like, oh, wow, this is a lot, but at the same time, it brought some comfort because you can start seeing the rationale and also start pinpointing the points that are going to be very, very complex. Bob, what's on your mind? Bob Morelli.
Sorry, had to get to the mute button. Sorry, I'm getting over a cold. Forgive my my voice. No, there's too much on my mind to go into it now. I know we're strapped for time, so fascinating. I love listening. I'm making notes. Just all kinds of stuff.
Great, good.
Thank you, Paul.
Yeah, you bet. Steve Fehr, any comments or observations? You're so involved in NASA estimating, and it'd be fascinating to hear your just general take on what you're hearing.
Yes, I guess one question is, where is uncertainty quantification in here? Is that kind of captured in the risk analysis and probability analysis?
It would be, yes.
Okay.
It would be those would be line items that are very specific to very specific. Instead of just putting a general purpose, a general line of uncertainty, it would be tagged to a very specific thing. And then you can, the team could put a general one if they want, but the uncertainty would come with systems specifically.
Yeah, good copy on that. Yeah, I think just the uncertainty in a system like this is just so much larger than the uncertainty that we normally deal with in construction.
Yes.
And probably at every scale. So that in itself is going to be a mess at every level. I guess the other comment / question is, Delimitations. So we're getting into kind of almost rabbit hole with all the potential different use cases. Are we trying to capture all of the potential like early stage use cases, or are we kind of delimiting to a point where we're not trying to construct cities or develop methods necessary to construct cities at this point, because we expect we'll learn a lot of lessons and have newer, better things in the future? That are we focusing specifically on near term level construction?
Well, I can give you my take on it. I think that's a good debate question for the entire team. My take on that is, and I'm one of 50, right? My take on that is that we price what's being discussed. And you know, it's not uncommon for estimating to price what we don't know the final product at the end, but we're still coming up with a structure that we can kind of predict what we think is going to happen. So I would say that that we're trying to always come to some sort of an end game conclusion, that, you know, we may or may not be right, but as much as possible. And if it changes through, if we take that approach again, I'm one of 50 of us, right? So please chime up. If the end game is, you know, let's say we do a prediction of the end game and the technology changes or the mission changes or whatever changes, or you do mock-ups and you find out, wow, that won't work, got to do something else, or the time changes. That's good information because we already have the detail and you can adjust the detail, and then it would learn, the process would learn faster. I mean, and again, I think it's a profound question, and I think we should have that in a you know, a session, just discussion, you know, because it is a very good.
Yeah, it may just be a point of practicality as we get into it, that if it becomes too difficult to try to do a general use case, that I think it would be acceptable to pare it down to just the more near term, that we're not trying to do, you know, an entire city of 1 million people on the moon.
Oh, I see what you're saying.
This, like the small industrial applications.
Got it. Sure.
Yeah.
Yeah, I think I see. I misinterpreted your conversation, your question. I see what you're saying. We're starting probably with just a simple moon base, and we may even only start with, you know, one. And this is kind of talking to Jabu very early on before this group grew. You know, start with just a landing pad, you know, and launch pad and a habitat, you know, and then using that to kind of grow. But I would say that we could probably use same methodologies as hospital campuses, you know, as far as that that methodology, maybe. But again, I'm one of many folks. But I love what you're saying. So
Yeah.
I don't
Paul?
think we would cut off. I don't think we would try to eat the horse. No, we would never eat the horse. Terrible. That's a bad. We would keep it at chunks that are relevant, and yeah.
That's a
I don't know
worst
why I
case
say
contingency
that's
plan.
a terrible one. Okay. Good question though. All right. So I'm looking at the time now. Patrick, I'm so sorry, but this was kind of an important thing to kind of get the team aligned.
This is very important.
Okay, good. I'd like to introduce Patrick now. And Patrick, you can see now the complexity.
Well, I'm sorry. Do you mind if I just interrupt for one second before we move on?
Nathan, how are you
I'm really
doing?
sorry.
Yeah.
I'm doing really well. Yeah, very interesting, and holy cow, you guys are doing what a remarkable job and detail that you have. I was thinking some of the same things that Steve was just thinking, and I wanted to provide a recommendation of maybe a somewhat different way of looking at how you choose the end state that you're going for, right? I think what you should do. And I'm no estimator, so I might be way off base with this. That's
No, or
not,
maybe not.
but what I would think about is, typically here in construction sites on Earth, there's different phases of the build, from initial earthworks to some of the foundations to now you're starting to put in some structure and etc. um when you're in the space case, you have much more limited capability to do a lot of things at one time, because you're kind of restricted to how much mass you can get there in any particular mission. And so one of the things that I've been getting after for a long time is trying to develop a clear vision of what is the sequence of construction that we need to undertake. And there are incremental steps to construction. So we don't have like a receiving yard on the moon. We don't have a landing pad on the moon. We don't have some of the things that we would take for granted here on Earth. And so what I would recommend doing is taking a few phases of construction based on either, maybe number, like a per mission scenario or payload mass scenario, and then estimate the costs based on that increment and have the costs build so that you can understand what the costs are at various stages of the overall construction project.
Well, look, Nathan, you said you weren't an estimator, and I think you are. Yeah, outstanding. Yeah, I think you're very intuitive in that, and I think it's in line with the direction that we're thinking. Sequence is going to be at a more intense state than anyone on this team has dealt with in estimating before. So you're absolutely spot on, and it's just great to get that type of validation from somebody like yourself. And Steve speaks very highly of your talents, by the way. And so thank you. That was spot on. And I think things like this is why it's so important to have this multifaceted lens expertise team that's solving this problem. So thank you. Great comment. Patrick Duke is heads design and construction for and design integration for Townsend, Turner Townsend. He oversees all the healthcare projects in the United States. He's graciously is helping us put this process together, implementation. He put a very good package together, and Patrick, just from day one, you've just been amazing. Help organizing this because it does take a lot of time. And so, without further ado, Patrick, if you could go through your great document that you put together and go from there. My apologies for the time.
No. This is fine. And I appreciate all the work that went into the detail that we just got to review. I've been engaged and involved in other such efforts where we're seeking to get expertise and knowledge from public and private industry, both. It will take that kind of collaboration and partnership to do this, and this is in the realm of possible. What we may have thought at one time was fantasy is now becoming more reality with the technology and the partnerships that NASA and others have already forged. I mean, you can think about this in there are discussions now with the Axiom project and some other projects around the International Space Station, working with private entities to create more commercial based options for people to do research and other things. There's talks about how do we ensure that, working on low Earth orbit insurances, but other orbit insurances. There already are commercial insurances for satellites and other things. But you have to start thinking about all these types of things that we deal with, but we take for granted. And how's that going to work in a habitat on the moon eventually, right? And so this is kind of what this group is going to be thinking about. So hopefully you can see my screen. If you can't, please let
We
me know.
haven't yet. Let me, I think that may be me. Let me stop sharing and I apologize. Okay.
Yeah, let me share.
Let me make sure I stop sharing here.
All right, you guys are able to see that on the screen?
Yes.
Okay, perfect. All right, so I'm just going to go through real quick. This is probably the most important piece, is what we're trying to do together. We've got this white paper that's coming out, which is kind of I would say that's the level set for this team on what we're trying to do in terms of really starting to look deeper at how this would be implemented. Focus on where, yes, on the estimating part, but the other parts that have to be completed in terms of what was just said. How do we get the space even ready for construction? It's one thing to estimate that, but then how do we plan to utilize and work with colleagues where we understand what payloads can be taken, where they can be dropped or not dropped, how all that will work. These are things that have not been done before, but they're smart people. So us working together and enabling communication and collaboration amongst people with a lot of different areas of focus is going to be the key. And we're not going to have all the answers, but we're going to have a lot of the questions that need to be answered. And that allows a blueprint for future research and focus that's going to be needed. And that's really the plan and the goal of this team and group. I'm serving as the lead in terms of the industry liaison role, where I will be working in between our industry partners and the academic and public agencies in making sure that we get the right collaboration and that we get the facilitation that's needed to make this a success.
Sure, Patrick, if I could just real quick, this is obviously a draft, and we do have more universities that are joining us, and
Yes.
some of them are on the line here. And where we'll be doing some student trade knowledge and stuff as well. So just FYI.
Yeah, if you're on here and your name's not on here, it's because it's not because we're just trying to omit you. It's just a draft in time.
Sure,
So
sure.
I'm going to go to this. Just if you look at a high level, these are the kind of expertise areas or focus we'll need to implement this. People that have an understanding of deep engineering in very difficult environments. Cost and time estimating. We got a lot of those folks. Space robotics and automation will be a big part of this. Mission planning, scheduling, data integration and modeling, and extreme environment logistics. These are all things that are at a high level are going to be needed in terms of expertise and collaboration to get this done.
Sure. Hey,
In terms
Patrick,
of our
may I
go
know
ahead,
you're short, but I just want to make sure I'm managing expectations. When we see space robotics and automation, how that applies to this group is production.
Yes.
So what is the output? And how is it applied to means and methods? So just so you know, just setting those expectations. Thank you, Patrick.
Yeah, you have to understand that before you can estimate it.
Yeah, exactly.
It's kind of important, but thank you for describing that.
Sure.
What we've broken down are these areas of expertise. If you have not filled out the form on the Notion site and constantly sends out links to the data room and the form, we want to know where you want to fit in. We've broken these down into, I think it's 11 items. But these are areas that we want to get people focused in as we prepare to have our facilitated sessions and start to look at how we're going to get stakeholder input. So just real quick, the way we're looking at this is we were working on this foundational white paper now. Hopefully we finish that draft at the end of this month so that we can push that out. Then what we want to do is we need all of you to get signed up for this, to commit to this in terms of the schedule we have now and the activities. but we'll also want you to come up with individuals or expertise that you think we're missing from the group to bring them in as part of this overall effort. We've got a lot of people here. We may not need that many more, but if there is someone that you know of in your network that absolutely we should have is involved in this exercise, we want them to be a part of that, and we want you to send those names directly to me so I can review those with our stakeholders and make sure that we can outreach to them. We're going to have info gathering sessions. The academic partners who have provided students and the students who they voluntarily want to be a part of this, they're going to start populating based on each of these areas. They're going to start populating and making sure that there's more data in the data room. Paul, I think that was kind of their initial area where they were going to focus on.
Yeah, and we have 4 students, John, Matthew, who many of you have met already, along with Anne and Sheik, who are online from UC Davis. And their task this year this quarter, which they've started, will be amassing research papers on these topics. And each of them are focused on a very specific lens.
Yeah. So we will do that, and then we'll schedule facilitated workshops around gathering input from stakeholders and then getting that input into a more refined white paper, which is how we'll finalize our work in September. So this is a group that will be working together. We will all participate and provide input. We will all get credit for that input, of course. Our 2 main tools, real quick, are Slack. We want to use Slack when we get the groups and assign you to the groups and the areas of specialty to do our workshops. We will communicate in Slack. There's a variety of reasons for that, primarily because it allows us to house all the information and feedback we get in one area, so we're not missing things in emails here and there, etc. And then the Notion site, which you've been on, otherwise known as the data room, which Anne set up and has done a great job of maintaining, that will become it will be our central repository. So you can already get this presentation on the Notion site. So if you're not able to get that link and go to it, you need to get set up for that. So this, I'm not going to have time to go through this. This goes through each phase that was on the overall timeline and what we're trying to achieve with each phase. And then the kind of the communication and reporting strategy. There is a participant agreement that we will be sending all of you after this call. This, very simply put, is to make sure that everybody is aware of what you're going to be participating in. We want to protect the institutions who are the lead institutions in terms of research and our public agencies. We want to protect their intellectual property. There are some things that you'll learn that may not be out, in terms of they may not be out in terms of public yet. It could be theories and things that are being used. We want to maintain confidentiality and protect those institutions. We also want people to understand that you're willingly and voluntarily being a part of this. So you're not seeking to gain any kind of ownership structure in the IP or anything like that. It's a very simple, you'll see it. It's a 1-page form basically that asks you to sign it. And we're just trying to protect our institutions who have so graciously asked us as private industry to come in and be a part of this. And I think that's reasonable. So if you have a problem with it, when you get it, I will be sending it out today to this group. If you have a problem when you get it, let me know, but it's an Adobe form. It should be very easy to sign and send back. That's just a highlight, Paul, real quick, in the time we had remaining. I'm sorry we went over a little bit, but that's a high level of what we're going to be working on and how we're going to organize the team.
Yeah, outstanding. And if we could capture Anne, if you could capture the chat. So if there's any questions or comments, we can send that out with the recording. This meeting has been recorded and will be placed in the data room. Look, I am always honored and thankful to hang out with such amazing folks that truly have a care in the field of estimating, and all of you are great thinkers. That's why you're here. So thank you so much, Patrick. Great work. And again, it's so great to see all of you. We'll send out a notice on when the next meeting is, and we'll have an agenda with Patrick's help. And of course, Anne's doing an amazing job. We'll be able to kind of think a little more in front than we have in the past. So I'm looking forward to that. If you want to contribute to the first round paper, we have a team of about 8 right now. Most are contributing around 3 to 4 to 5 paragraphs at the most. If you'd like to, we can discuss that. But there will be other rounds of paper that you'll be able to be involved in if you're not in the first round. All right, but you will be mentioned. So just know. Okay. Thank you.
Thank you very much. I appreciate that. Nice presentation.
Great. Thank you.
Thank you.
Hope everybody
Thanks,
has a
all.
great
Thank
great
you
day.
guys.
All right. Bye-bye.
Thanks, Paul. Have a nice weekend.
Bye. Thank you.